Equation of straight line in the form ax plus by plus c equal to 0 is called general form of straight line. And in this lesson we will prove that it always represents a straight line and it can be reduced to any standard form. Let's get started and consider case 1 when a is equal to 0 and b is not equal to 0. So for case 1, when a is equal to 0 but b is not equal to 0, then the given equation, which is ax plus by plus c equal to 0, and if we substitute a is equal to 0, this will give us 0 times x plus by plus c equal to 0. So from here we can find the value for y. This would be by equal to minus c, and this will give us y is equal to minus c over b. And this equation y is equal to minus c over b is equation of straight line parallel to x-axis, which is a line parallel to x-axis, which is straight line parallel to x-axis. So now if we consider it otherwise, when a is not equal to 0 but b is equal to 0. So case 2, when a is not equal to 0 but b is equal to 0, then what happens to the given equation? Then equation ax plus by plus c equal to 0, this will reduce to the form ax plus 0 y plus c equal to 0. So this will give us ax equal to minus c, means x equal to minus c over a, which is a straight line, parallel to y-axis. And the equation for this, x equal to minus c over a, is this. So in both cases, whether a is equal to 0, b is not equal to 0, or b is equal to 0, a is not equal to 0, in both cases this equation represents a straight line. And now we are going to consider third case, when both a and b are not equal to 0. So case 3, when a is not equal to 0 and b is not equal to 0, then equation ax plus by plus c equal to 0 can be reduced to a slope intercept form, which is also a standard form of equation of straight line. And for reducing it to slope intercept form, so let's reduce it to slope intercept form. And for that purpose we are going to isolate y, and for isolating y we will need to move all the terms independent of y from left side to the right side of equation. So this will give us by equal to minus ax minus c. Dividing both sides by b, if we divide both sides by b, that will give us y equal to minus a over b x minus c over b, which is a slope intercept form, which is slope intercept form, and coefficient of x is slope, so m is equal to minus a over b, and y-intercept is equal to minus c over b. From this we can see that here this point b, which is a y-intercept, its distance from x-axis is equal to minus c over b. Therefore coordinates of b would be 0 minus c over b. Exact location of b will depend upon the values of c and b, but this is just a good guess. And now we want to reduce this equation into slope point form or point slope form. So let's reduce this into point slope form. Point slope form. And for reducing it into point slope form, we are going to find a point on the line for reducing it to point slope form. Choose a point on the line where y is equal to 0. And if we choose from the line y is equal to 0, means that ax plus by plus c equal to 0. If y is equal to 0, then this is ax plus b into 0 plus c equal to 0. This will give us ax plus c equal to 0, and here we will have a point for which x is equal to minus c over a. But for this, what is y is already 0. But isn't it x-intercept? Because for x-intercept, y is equal to 0. So the point a minus c over a 0 is x-intercept, and this can be taken as a point on the line, and we already know what is slope. So if this is a straight line, which already has a point a, or let's call it a minus c over a 0, if this is a point, we already know what is slope of this line. Slope of this line is equal to minus a over b, which we have calculated in slope intercept form. So now if we choose any variable point p, x, y on the line, then this point can be taken as x1, y1, then point slope form of line would be y minus y1 equal to m into x minus x1. We now have a point y minus, for which y1 is equal to 0, is equal to slope, which is minus a over b into x minus c over a. So this is point slope form of straight line. Y equal to minus a over b into x plus c over a is required point slope form for the general equation of straight line. And now we are going to calculate two point formula of straight line, and that is easy because this is number 3, and this is easy because on the line here we already have b, which has coordinates 0, minus c over b. This is y-intercept, and here we also have a point a, which is x-intercept, and coordinates are minus c over a 0. If this is labeled as x1, y1, and this is labeled as x2, y2, to find equation of straight line from 2 points is not hard, as we have done before. Then equation of straight line with 2 points would be x minus x1 over x2 minus x1 equal to y minus y1 over y2 minus y1. And now it's just matter of substituting the values of x1 y1 and x2 y2. So x minus x1 is minus c over a, so this will become ultimately plus c over a divided by x2, which is 0, 0 minus, and minus again will become c over a, equal to y minus y1, which is 0, over y2, which is minus c over b, minus c over b minus 0. So this is equation with 2 points on the line, x plus c over a divided by c over a equal to y divided by minus c over b. And if we want to further simplify it, we can certainly cross multiply this. So this will become minus c over b into x plus c over a equal to c y over a. It can be simplified to desired form, but this is required equation, which is required equation. And now if we want to reduce it to the intercept form, for intercept form, we know that equation of straight line in intercept form, equation of straight line in intercept form was x over a, which is x-intercept plus y over y-intercept equal to 1. So we have for given equation we have x-intercept. X-intercept was calculated equal to minus c over a, and y-intercept was calculated equal to minus c over b. Therefore, writing this equation in intercept form is not hard at all. X over minus c over a plus y over y-intercept, which is minus c over b, equal to 1 is required form, intercept form. And now if we want to write this into the symmetric form, fifth, that is symmetric form. And what was the symmetric form? The symmetric form of straight line was x minus x1 over cos alpha equal to y minus y1 over sin alpha equal to r. So we need to find out the values for sin alpha and cos alpha, but x1, y1 is a point on the line, and we know the point on line, we can take a as point on the line. So what was the values for x1, y1? Those were minus c over a, 0. This can be taken as x1, y1, any point on the line. For finding value of sin alpha and cos alpha, we will consider slope of line is equal to minus a over b, but also we know that slope of line, if it makes an angle alpha with x-axis, then slope of line is equal to tan alpha as well. This is established fact, and from this, if we make a triangle, here if we make a triangle, and of course this is going to be a right triangle, and if this is taken as angle alpha and this is a, this is b, then by Pythagoras theorem this would be a square plus b square. Hypotenuse is equal to sum of squares of perpendicular and base. So from here, sin alpha and cos alpha can be calculated. Sin alpha is equal to a over a square plus b square square root. But because we have no idea in which quadrant this alpha lies, therefore we are going to consider both plus and minus signs, and cos alpha will be equal to plus minus b over a square plus b square square root. And now we have values for sin alpha, cos alpha, and x1, y1. For reference equation 1, we can substitute these values. This implies x minus, what is x1? x1 is c over minus c over a, so this will become plus c over a divided by cos alpha. So cos alpha would be plus minus b over a square plus b square square root equal to y minus 0 over sine alpha, and sine alpha would be plus minus a over a square plus b square root equal to r is required equation of straight line in symmetric form. Is required symmetric form of straight line. And now we are going to derive this in this was number 5 and now number 6. Number 6 would be the normal form of straight line. What is normal form of the straight line is x cos alpha plus y sine alpha equal to p, where p is perpendicular distance of the line. If we had, let's say, if we had this grid here, then this line from here, if this is y-axis, this is x-axis, and this is the line, then this perpendicular distance is p and this angle is alpha. Okay, let's call this as equation 1, and comparing with equation we have is ax plus by, and let's write, instead of plus c, let's write it equal to minus c on the other side, and compare both of these equations. Then x, and this would give us a over cos alpha is equal to b over sine alpha, like ratio of the coefficients of x and coefficients of y should be same as ratio of the constants. This would be minus c over p, or the inverse ratios would be same as well. This means minus c over p is equal to a over cos alpha. A over cos alpha is equal to b over sine alpha. It doesn't matter if we write those constant terms before. And now by reciprocating, what we will get is p over minus c is equal to a over cos alpha over a is equal to sine alpha. We have simply reciprocated the ratios, and that shouldn't hurt, because we have a property in ratios that a over b is equal to c over d is equal to a square plus c square root over b square plus d square root. So this is we are going to use, and this will give us cos square alpha plus sine square alpha over plus minus a square plus b square. The value we will take plus or minus depending upon the sign of c. So here plus or minus of a square plus b square is chosen according to the sign of c. If c is positive, we take plus a square plus b square. If c is negative, then we take minus a square plus b square. So from this one, we have p over minus c is equal to cos alpha over a is equal to sine alpha over b is equal to 1 over plus minus a square plus b square, and from this we can calculate values for p, which is equal to minus c over plus minus a square plus b square, and cos alpha would be equal to a over plus minus a square plus b square, and sine alpha would be equal to, let's write down sine alpha here. Sine alpha would be equal to b over plus minus a square plus b square. There should be no confusion about the sign. We already have decided that the sign of plus minus a square plus b square under root will be chosen as sign of c. So substituting these values of sine alpha, cos alpha, and p in standard form, x cos alpha plus y sine alpha is equal to p, what we are going to get is x cos alpha would be ax over plus minus a square plus b square, and then would be y, and with y would be sine alpha, so that would be plus by over plus minus a square plus b square is equal to p, and p would be equal to minus c over plus minus a square plus b square. This can be further simplified as the denominator on left side is same. This could be ax plus by over a square plus minus a square plus b square is equal to minus c over a square plus b square.